the last 3 months, because of COVID-19, schools have been shut. I hope that these materials that we present today will be beneficial to students in their final year of secondary or high school.
Hi everyone. In our mathematics class today, we're going to be looking at the bearings and the distances. What do we mean by bearing and distances? Bearing are the clockwise angular relationship between two distant places measured in degrees from the north. The relevant direction are the 4 cardinal points. And you know that the 4 cardinal points that we have are the north, the south, the east, and the west. For example, a bearing of 42 degrees east means a turn of 42 degrees. A bearing of 68 degrees west means a turn of 68 degrees. So from the north, based on the 42 degree east, means a turn of 42 degrees. So from the north towards the direction of the east. So proper understanding of solution of triangles, sine and cosine formula must be known to solve problems on bearing and distance. And if you can remember that in our last classes, in our previous lectures, I've discussed with you extensively on the sine formula, the cosine formula, which is going to be applicable in the bearing and distances. Let's quickly take a look at these 3 examples. Example 1. 3 towns A, B, and C are such that the distance between A and B is 50 km, and the distance between A and C is 90 km. If the bearing of B from A is 0.75 degree, and the bearing of C from A is 310 degrees, find A, distance between B and C, and B, bearing of C from B. Let us look at the diagrammatic illustration. If you look at this diagrammatic illustration, they said 3 towns A, B, and C are such that the distance between A and B is 50 km, and the distance between A and C is 90 km. Then I said, if the bearing of B from A, you see this statement, B from A, which simply means the journey starts from A. That is, look at the A. So, and I draw from this point to this point, that would be 90 degrees. But they were referring to that if the bearing of B from A is 75 degrees, so I assume this is our 75 degrees. So a straight line is being drawn towards to B, because the journey starts from A. Then, and the bearing of C from A is 310. That means the journey also starts from A to C, which is from this point, this is 90 degrees, to this point is what? Is 180 degrees, to this point is 270 degrees, and to this point I make it to be 310. That is why I draw this line to this point. And don't forget, the distance AC is 90 km, and the distance AB is 50 km. Then I join from C to B together. So now, the A part, to find the distance between B and C using cosine formula, because if you look at the diagrammatic illustration, we were given line AC and we have line AB, which simply means we have our included angle, because from this point to this point is 75 degrees to B. Then from this point to the bearing of A, from A to C is 310, which simply means the remaining angles to make it a complete revolution 360 is 50. So if we now sum this 50 to 75, that means the angle that's subtended at A is 125 degrees. That's the reason why we have the included angle of 125 degrees. Then we are about to use the cosine formula, then which states that we are looking for the side A, which is the distance BC. That is A squared equal to B squared plus C squared minus 2BC cos A. So what is our B? B, which means the angle B is facing this side. So which means that this line AC is our side B. And that means our B is 90 kilometer, which is 90 squared, plus 50 squared, which is our side C, 50 squared, minus 2 times 90 times 50 times cos 125. So 90 squared will give us 8,100 and 50 squared will give us 2,500, minus 2 times 90 times 50, that will give us 9,000. Multiply by cos 125 is negative 0.5736. Now, if we sum 8,100 together to 2,500, we're going to get 10,600 plus 5,000. That is the multiplication of 9,000 multiplied by 0.5736. Then negative times negative will give us positive, which will result to this. Then our a squared will now be what? Once we sum this, we are going to have 15,762.40. So we are going to take the square root of both sides because what we are looking for is our side A. So taking the square root of both sides, A will be equal to 125.5484 kilometer. So the nearest kilometer will give us 126 kilometer, which simply means the side A is going to give us 126 kilometer. Then let's take a look at the question, the B question. They said the bearing of C from B. That simply means the bearing of C from B. That means the journey starts from where? From B. So, and you know that from here to this point is 90. This one is also 90. And being that the bearing of B from A is 75, which makes this one to be alternate. That is why this side is 75 degrees. If we sum up all these angles together, we're going to have, that is, we're going to have the summation of all those angles together will give us, that is 200. Because if you look at it, if you look at this side, 90 plus 90, that is 180. And if we sum 75, that will give us 255. So now, what remains for us to look for is this angle B. So it is this angle B, by the time we sum it up, that will now make us to know the addition from this point on to this point will be the bearing of C from B. So now, let's take a look at it now. So for us to look for that angle B, that means we're going to make use of what? Sine formula. That is what makes me to use this. Sine A over small a equal to sine B over the side B. So we know that the angle A is 125 over A, which is 125.5476. Please note that whenever you are doing some calculations and they ask you to round up to the nearest kilometer and the calculations still continue, make sure that you don't use what you round up. You should make use of what is being given from the calculator when you pressed it. So that's the reason why I didn't make use of the one I round up, which is 126, but I made use of what? 125.5476 kilometer. So equal to sine B over 90. So when I cross multiply, and the whole thing give me what? Sine B, because I make the sine B as a subject of the relation. It gave me what? Is 0.5872. Then we're going to take the sine inverse of both sides, which means that B, which is the angle B, will give us sine inverse of 0.5872, which will give us 35.96. Then angle B to the nearest degree is going to give us what? 36 degrees. So from what I said the other time, hence the bearing of C from B will be the addition of 90 plus the 90 plus 75 plus the 36, which is the angle B, which will make the total of 291 degrees. That simply means the bearing of C from B is 291 degrees, as it's been explained here. Now, let's look at the example 2. They said two ships, P and Q, left a port R at the same time. Q sailed on the bearing of 150 degrees, while P sailed on the north side of the Q. After a distance of 8 km and 10 km by P and Q respectively, their distance apart was 12 km. So find the bearing of P from R. So now look at the diagrammatic illustration. You know that P and Q left a port R. That means the journey began from where? From the port R. So Q now sailed on the bearing of 150 degrees. That's the reason why I make use of what? The Q, that is from this point to this point, is 150 degrees. So it sailed on that bearing. Then YP sailed on the north side of Q, which means this is the north side of Q. P now sailed there. That is why this is the journey of the P. So now, what we are now looking for, then I say after the distance of 8 km and 10 km by P and Q, that means the journey of P is 10 km, while the journey of the Q is 12 km. No, the journey of P is what? 12 km, while the journey of Q is 8 kilometers. But don't forget, the distance apart is what? 12 kilometers, which is what we have here. So now we are to find the bearing of P from Q. That is the bearing of P from Q, which simply means what we need right there is what? The journey from R. You understand? Find the bearing of P from R. That means the journey begins from R. So for us to get the bearing of what? Of P from R, that simply means there are some angles that are needed. And what are those angles? That's the reason why we need the angle P. So that's the reason why we make use of this. I think we make use of sine formula, that is sine P over P, the side P, equal to sine Q over the side Q. So after the substitution of all those information, you know that the angle P is what is not given. That is what we're looking for. And we know the angle Q to be 30 degrees. The reason why it is 30 degrees is that, you know, when we draw, when this one make an angle of what? 150 degrees. You know, from this point to this point is 150 degrees. And if it make a complete to this point, it will be 180. So that means if we less 150 from 180, we're going to have 30 degrees. And this one being 30 degrees will be alternate to this angle, angle Q. So that's the reason why angle Q is 30 degrees. So after our manipulations here, that simply means our sine P at the end of the day will give us a 0.333. So, and we're going to take the sine inverse of both sides, where we're going to have P equal to 24.62. And if you round it up to the nearest degree, we're going to have 25 degrees, which simply means the journey of what? Of P from R. Don't forget, these are R. That is, the angle that's obtained at this point is what? Is 25 degrees if we round it up. So that is why the bearing is what? From, that is P from R is 25 degrees. So let's quickly take a look at the third example. The third example states that an aeroplane X, whose average speed is 500 km per hour, leaves Kano Airport at 7:00 a.m. and travels for 2 hours on a bearing of 50 degrees. It then changes its course and flies on a bearing 120 degrees to an airstrip A. Another aeroplane Y leaves Kano Airstrip, that is around 10 a.m. and flies on a straight course to the airstrip A at 11:30 a.m. Calculate the average speed of Y correct to the 3 significant figures. If you look at the diagrammatic illustration, the whole journey begins from where? From Kano. So now, X begins its journey at a bearing of what? 50 degrees. That is why this is 50 degrees. We draw it to the what? To the X. Don't forget, at 500 km per hour for 2 hours. That means it takes X to fly to this point at what? At 2 hours. So if it takes X to fly at 2 hours, and don't forget they said it's 500 km per hour, so that means for 2 hours the distance between the Kano and the X is going to be what? 1000, because for every 1 kilometer it is what? 500. So that means if it is for 2 hours, that's the reason why this side is what? 1000 kilometers. We should take note of that. Then it now changes course and flies on the bearing of 120 degrees. Look at this. X changes its course to 120 degrees. So these are 120 degrees. It flies to the what? To the airstrip A. So this is the airstrip. So if you take 120 degrees, that simply means the remaining one to make it, because this is 90, this is 90. The remaining one to make it 180 will be what? 60. That's why this angle is 60 degrees. And don't forget, you know that the bearing of X from K when it was leaving Kano is 50. So it's alternate to this point, which makes it to be 50. That means if you sum these two angles together, you're going to have 110 degrees, which makes the angle X to be 110 degrees. And don't forget, in as much as it states that Y now leave Kano to the what? To the west side of what? Of the airstrip. Because if you look at it, they said another plane Y leaves Kano Airstrip 10:00 a.m. and flies on a straight course to the airstrip. And you know that the airstrip is at the western part. That simply means it flies from what? The eastern part of Kano straight to the western part of the airstrip. So that's the reason why we maintain a straight line at this point. And don't forget, from this point to this point is 90 degrees. And since this one is 50 degrees, that means the remaining angles that's obtained here will be 40 degrees. That's the reason why the angle that's obtained at the Kano airport is what? Is 40 degrees. Now, what are we going to do to find the remaining angles? That means, you note that I told you that the total sum of an angle in a triangle is 180 degrees. Since we know the angle X, we know the angle K, which is Kano. That simply means we will sum all the angles together, which will give us 180 degrees. That means 110 degrees plus 40 degrees plus A, because our A, we don't know it already. So that will give us, if we sum 110 plus 40, we're going to have 150. So A plus 150 equal to 180, where we're going to collect the like times. And if we collect the like times and we take away 150 from 180, we're going to have A equal to 30 degrees. So now, to now find the distance KA, which is what we are looking for based on the question, because if we didn't get the distance of the aeroplane that leaves Kano to the airstrip, we will not be able to calculate the average speed, because the average speed is what? The total distance divided by the time taken. Now, for us to now calculate the distance KA using the sine formula, that simply means sine x, which is what? Sine 110 over the side x, which is the side x is the y, equal to sine 30 degrees over 1000, which is the side A. So that is what I did here. And after our manipulation, we're going to have our y to be equal to 1879 kilometer. That is correct to the nearest kilometer. Hence, the average speed of y, correct to three significant figure, is now going to be what? You know, average speed is what? Total distance over the time taken. And what is the total distance? The total distance is 1879.3852 kilometer. Then divided by 1.5 hours. How did I go the 1.5 hours? Remember that they said it took 1 hour 30 minutes for the aeroplane Y to move from Kano Airport down to the airstrip. That simply means if it is 1 hour 30 minutes, what is the 30 minutes in hour? That means we are going to divide 30 divided by 60, which will give you 0.5. Then sum it to the hour, that will give you 1.5 hours. So if we now divide this, we're going to be having 1252.9235 kilometer. That means to the nearest kilometer, our average speed, now to the three significant figure, that simply means our average speed is going to be what? 1250. If they said three significant figures, that simply means I only want to see three figures. But if it is in thousands, that means after the three figures, the remaining number should be 0. So that's the reason why it's been 1250 kilometer. Now, the second question I say, the direction of flight y correct to the nearest degree. That simply means if you look at the direction of the flight y, like I told you, if it begins the journey from this point, that means to this point, you know, it's travel on a straight line, which makes a 90 degree. That's the reason why it's very easy. The direction of flight y correct to the nearest degree is 90 degree. So that makes it very, very simple. So now, what we are not going to do here is that you are going to solve, we are going to solve this. So now, you are going to look at this practical question. This practical question, please practice it based on what is being explained earlier. But before then, I wish you the very best until we meet in our next class. Bye-bye.